Section 8-5, constructing a function to model a linear relationship. Part 1, writing linear function rules using initial values. At time t equals to 0, a bicyclist begins riding at a constant speed. 10 minutes later, the bicyclist had traveled 2.5 miles. Write the linear function rule that models the distance d the bicyclist has traveled after any number of minutes t. Now remember, distance is equal to rate times time. Okay? Distance is equal to rate times time. That's your formula. T-I-M-E. Okay? And that's rate. We could put that in parentheses. Rate times time. They're multiplied together. Okay? So distance is equal to rate times time. So D is equal to RT. Okay? So anytime we see that, D is equal to RT, that's what that means. Distance is equal to rate times time. So we have been given the initial time is 0, okay? A bicyclist begins riding at a constant speed. 10 minutes later, the bicyclist has traveled 2.5 miles. Write the linear function rule that models the distance d the bicyclist has traveled after any number of t minutes. Now, the first thing we're going to need to do is we're going to need to determine our slope. So let's look at this graph. Look at the graph given here. We need to first find the slope of the line, okay? So, started at the origin, 0, 0. He traveled 2.5, 1, 2, 2.5. So the rise is 2.5. The run is 10, okay? 10 is t. When you look at your horizontal axis, you have a little t here. This is representing time, okay? When you look at your vertical axis, this is representing d, which is distance. Starting at the origin, he traveled 2.5 miles in 10 minutes. Okay, so your rise was 2.5 and your run was 10. So your rise 2.5, your run is 10. 2.5 divided by 10 is 0.25. So therefore your rate of change or your slope is 0.25. Okay? Now, find the d-intercept, where the bicyclist started. Well, where did the bicyclist start? At the origin, okay? So your y-intercept would be 0. So then it says, finally use the slope and the d-intercept to find the rule, all right? So, remember, you've got y equals mx plus b. Y equals mx plus b. But in our problem, we've got distance is equal to your rate of change times t plus b, okay? So here we're trying to find the linear function rule that models the distance of the bicyclist. And so that is our d. So therefore I have d is equal to my slope, 0.25t, plus what is b? What is my y-intercept? It was 0. That's where they started, at 0. So the linear equation rule that models the distance that the bicyclist has traveled is d equals to 0.25t. that is the linear function rule that models the distance that the bicycle has traveled, is d equals to 0.25t.